Okay, students, let us go to another organic chemistry discussion, aromaticity. A 2019 question. 2019 question. Among the following, the number of aromatic compounds is or are. Is or are. You have to answer the number. You will have such questions. Numerical answer type question. You will have numerical answer type question. You have to write the answer if it is 1 or 2 or 3 or 4 or 5. Okay? How many? What are the aromatic? Is this aromatic, this aromatic, this aromatic, this aromatic or this one? Okay, let us discuss. How do you check the aromaticity? What is the trick for identifying aromaticity? Okay. You have to check 4 factors. First, is it cyclic? Yes, all are cyclic. Second, there should be planar. Third, there should be conjugation. Fourth, there should follow 4n plus 2 pi electron. If a molecule follows all these things, all these features together, that molecule will be aromatic. If it follows 3, no. If it follows 2, no. If it follows any one of these features, no. Aromatic molecule should follow all these 4 together. Okay. Now, you have to keep another one. Every molecule will tend to be aromatic. Every molecule will tend to be aromatic as possible to themselves. Okay. First, you should, these two are simple. Cyclic, okay, simple, you know that. Planar, if there is sp2 hybridized, sp2 hybridized carbon, sp2 hybridized carbons, if all carbons are sp2 hybridized, that should be planar. This is sp2, this is sp2, this is sp2, 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 okay? Okay, I'm sorry, here something missing. Therefore, this is sp2, sp2, sp2. All double bonded carbons are sp2, 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 sp2. Okay, sp2 hybridized carbon, that is planar. Very simple. How do you check the sp2 hybridized? Carbon should be double bonded. Now the conjugation, it requires some details. What is a conjugation? There are different types of conjugation. First is alternative double bonds. Double bonds should be alternative. Okay, you should have alternative double bonds like this. Or next, alternate double bond and lone pair. Alternate double bond and lone pair. That's also conjugate. I will tell you one point. Suppose you have a molecule like this. A double bond, a lone pair. Here oxygen. Heteroatoms. Alternate double bond and heteroatoms. Alternate double bond and heteroatoms. Okay, you have a heteroatom at the alternate position. There will be also conjugation. Okay, there will be also conjugation. Therefore, I have said you alternate double bond or alternate double bond and lone pair. Third, alternate double bond and positive charge. Okay, what is that? What is that? Very simple. Suppose you have a structure like this. There is also conjugation. There is also conjugation. Second, alternate double bond and negative charge. Negative charge. There is also conjugation. Therefore, how many? Alternate double bonds, alternate double bond and lone pair or heteroatoms, alternate double bond and lone pair or heteroatoms, alternate double bond and positive charge, alternate double bond and negative charge. Okay? Yes. These are then alternate double bond and radical. There is also conjugation, but may not be the part of the high resonance. Sorry, aromaticity, but it also shows the conjugation. In the aromaticity, you have to check following cases: double bond and double bond and heteroatoms, oxygen, nitrogen, sulfur, like that. Double bond and positive charge, double bond and negative charge, alternate positions. Okay? Fine? Yes. Oxygen, nitrogen. Now let us check one by one. Then 4n plus 2 pi electron. We simple that 4n plus 2 pi electron, that is 2 pi electrons or 6 pi electron, like that. 8 pi electron, 10 pi electron, like that. Like that. Okay? Haeckel's rule. Now let us check. Therefore here this is very important. Conjugation is very important. Let's just check. Okay. All are cyclic, sp2, 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 planar, double bond, alternate. Now there is a lone pair. There are 2 lone pairs. Here also 1 lone pair. But I said you, this lone pair part of the conjugation. This is not part of the conjugation. This is the part of conjugation. You know why? I said you, molecules themselves tries as much as to be the part of aromaticity. They themselves tries. They have inherent tendency somehow to be the part of aromaticity. Therefore, this sulfur very trickily gives 1 lone pair to the aromatic conjugation, other does not give. Now suppose there is a question, what is the hybridization of this sulfur? This is also sp2. This is also sp2. Then only it will become the part of the planarity. How do you prove that? sp2, 3 hybridized orbitals, 1 non-hybridized. Okay, that is why it has a bend shape, you know. 2 hybridized and 1 lone pair. This lone pair. 2 bond pair and 1 lone pair. Which lone pair? This is part of the conjugation. It is not the hybridized lone pair. Fine. Okay. Now let us come to here. Double bond, alternate double bond. Now here a lone pair. This nitrogen has sp2 hybridized. Okay, I agree. Here also a lone pair. Does it the part of hybrid conjugation? This is not the part of conjugation. Not conjugation. Why? Why this risk? Yes, this molecule wants to be the aromatic. Therefore, this is aromatic. This is aromatic. 2 double bonds, 1 lone pair. They are in alternate position. This lone pair in alternate position with this double bond, and this also alternate position in this double bond. But this is not part of the conjugation. Now, this is a boron. Boron, here an empty orbital or a positive charge. Yes, very careful. This is the part of conjugation. This boron, there is an empty orbital. Because of that empty orbital, you can imagine there is a positive charge. And this is a conjugation. But here, 4n pi electrons. Therefore, this molecule is anti-aromatic. Very, very careful. This molecule is anti-aromatic. Not aromatic, but anti-aromatic. What is the condition for anti-aromatic? Cyclic, planar, conjugation, 4n pi electron. 4n pi electron. This follows this. Another example is this one. Okay. Therefore, it is anti-aromatic. There is resonance, there is conjugation, there is, what is the hybridization of this boron sp2? Therefore, it is planar. It is a part of the conjugation. Alternate position. You imagine a positive charge here. Why do you imagine a positive charge here? Because boron has a empty orbitals. Okay. Now come here. This carbon sp2, this carbon sp2, this carbon sp2, this carbon sp2. Because double bonds. Here a lone pair. Here a lone pair. Yes. Now, my dear students, to attain the aromaticity, this molecule behave like this. Very careful. Double bond. O minus plus charge. NH. O minus plus charge. My dear students, careful here. This molecule, this carbon has a positive charge. Nitrogen has a lone pair. This nitrogen also a lone pair. Look at it here. How beautifully. Here a positive charge. Here a positive charge. Why this molecule takes such a risk? If you ask me why this molecule takes such a risk, the answer is only to be aromatic. Because aromatic molecules are stable. This molecule not like this. This is always like this. Here a positive charge, here a negative charge. Here a positive charge, here a negative charge. Now look at here. Double bond. Alternate positive charge. Now, yes, here a conjugation. At different types of conjugation. Look at this part. What is this? Lone pair, positive charge, lone pair. This is also conjugation. My dear students, remember, this is a conjugation. Of course, this can come here, or this can come here. There is a conjugation. When it comes here, positive charge will here. When this lone pair comes here, positive charge will here. Therefore, there is a movement of electrons are possible. Total how many electrons? 2 electrons here, 2 electrons here, 4. 2, 1 pi bond also 2 electrons. Therefore, it also 6 electrons. Therefore, this is aromatic. Okay, here 2 lone pair, but this lone pair part of the conjugation. And here a positive charge. There will be a question. Suppose a question, what is hybridization of this nitrogen? If this nitrogen is a part of aromaticity, blindly, straightly answer, sp2, 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 sp2. Because if these are a part of aromaticity, there should be planarity. Planarity means their hybridization should be sp2. Okay? Therefore, here answer is this is aromatic, this is aromatic, this is aromatic, this is aromatic. Answer is 4. If you can answer 4, you will get the full mark. And this is only not aromatic, but you cannot simply reject it. It is anti-aromatic. Okay? I hope this topic is clear.